All right. So I hope you're comfortably seated for our last talk. And please join me in welcoming Cedric Hnyda and Zdene from Cloudera, who will speak about Kubernetes for data platforms at what nobody told you about. So I'm sure you will hear a lot of things that you haven't heard yet. Big applause for Cedric and Zdene.
So hi everyone, I hope that you enjoy stories because we will just try to show you some story. So first, we will introduce ourselves.
So hello everybody, my name is Cedric Hnyda. As you can hear, I am French, as this accent which is very difficult to get rid of. I am a director of engineering at Cloudera, but I was working before in a startup called Tycoon, which got acquired by Cloudera last year. And I've been playing and breaking things with Kubernetes for a long time. And it's fun.
Thanks. So me, I'm Zdene. I hope that you know me. I'm working in the Cloudera as the principal engineer, but maybe you know me because of my non-working stuff, because I'm also the CNCF ambassador. I'm organizing cloud native product meetups and also this conference, DevOps Day conference and stuff like that. So yeah, that's about me. And right now, we'd like to share something about the company.
So we are working for Cloudera. Cloudera is a company which was created in the 2000s. It has many enterprise clients which have very strict security and compliance requirements. You don't really hear often about Cloudera, but many of the customers are top financial institutions, banks, states, big pharma companies, and basically many companies are using Cloudera's products.
If you use the big data, so you probably use us, especially if you wanted to use your own on-prem or your hardware, because there is almost no alternative. I can be sure that there is no good alternative for us, of course. So we like to show you also some roadmap about the history of the Cloudera. And it's quite important because Cloudera has some special steps, like that every 3 or 4 years, we can call it like a new start. There is a whole reconstruction of everything. And this year, this is it's start of the next phase. Yeah, we are making almost one of the biggest change in the company. So it's the reason why we are also trying to hire some people. So you can see that we have also some big names as our clients. So this is just for an overview of which companies are using us and also what we are using it. So
please raise your hand if you think that Kubernetes is easy. Really? So the answer is it can be easy, but it depends on what condition you are running it. So let's imagine you want to run some AI workload, or you want to run some big data jobs, some Spark, some Hadoop, to run some Kafka. So you need a cluster, right? One or more cluster. So you want to get started in a simple way. So what will you do?
Yep, and we will try to show it on some story. So here's some memes, and it's a storytelling.
So where will you get started? I will go to the cloud. Nowadays, there are many good managed Kubernetes solutions. So I will go either on Amazon, on Azure, or on Google, and I will use their managed Kubernetes offer. Why? Because everything is working there.
Of course, till it's just stop, or if you are out of your bills.
You have working load balancers, you have storage working, all the services of the cloud providers, DNS, certificates, you can have database as a service, encryption also, security. Everything is ready for you.
This is good, right? So maybe just think about it if you have some specific data, which are, especially GDPRs, or maybe even much more sensitive data like your know-how. So maybe you don't want it to, run it on somewhere because you know some rules of these hyperscalers that maybe they share the data with someone else, or they have to if they are asked for. So maybe you wanted to run it also on your on-premise, right? So
now your life has been easy so far, but you need to have a hybrid strategy. This doesn't come from you, but you are asked to prepare it. So what do you do, Zdenek?
yeah, no. So when I have to store some data, I say, okay, the hybrid cloud is the best solution. Yeah, it's quite easy to run it. So I can start like running on my local machine and it works. Everything works on my local machine, of course. So then maybe I will try to, use some enterprise solution like VMware or stuff like that, because it provides me some environment and then I can run my own Kubernetes cluster there. It's still easy, right? Oh, but maybe you care about the cost, not only because of the VMware itself or other solutions, but maybe even because of if it's not running in the cloud or if it's running on the VMware, maybe it's cost the same for you. But maybe if you don't care about the big data, so maybe you will not have any issues with that. But if you have terabytes of data, which should be not only stored but also transferred via wire, so yeah, you should handle something. And of course, if you are running something on the bare metal, so there are some common issues. I hope that every one of you tries to install the Kubernetes cluster on your maybe virtual machines. But have you ever tried to make some performance tests of the storage? Have you ever tried to use your load balancers? In cloud it works quite good, right? But how is working when you are running on the bare metal? So we are moving to the next steps, and yeah, of course, when we wanted to run on the hybrid cloud, of course, we need some hardware.
So now you need to run Kubernetes on your own hardware. So what do you do? My first idea would be to get a bunch of servers and, as Nick said, install Kubernetes there. I will find a way to do it. IT department will prepare me a bunch of servers and I will install Kubernetes there and everything will work fine. But what about storage? How do I get an enterprise solution, something highly available, something performant? I just have a bunch of servers. So how do I get that? I have to make a choice here.
Sure, you can start like, just come on. We can use the CNCF landscape. There are solutions for it, even for the storage. You have the OpenBS. You can use the Ceph for the storage, but maybe it works if you have tens of nodes. But how does it work if you have the thousands of them? Not like 1,000, but maybe thousands of them. So did you try it? No, nobody.
Nobody try here?
Ah.
One. Yeah.
Was it fun? Was it fun to maintain?
Yeah, you start to feel the pain. If you are running on the cloud, everything works out of the box. But once you start to run it on-prem, every abstraction you could use in the cloud, it's not granted anymore. You need to find a solution to get it. You need to do it yourself. And for every cluster, you need to find again a solution for this. So we have a problem with storage. There are solutions like Ceph, OpenEBS, or you can use some solution like some boxes like Pure Storage. At least you fix that problem. But what about other solutions for load balancers? Because you need to expose your AI workload or your applications, right?
And there is also another story. I don't know how, if you already have some on-prem servers, maybe even for a longer time. So did you try to order the same server for last 4 years? Or do you mean that if you order the same server with the same setup, is it the same every year when you order it? Maybe not, and you can get some issues, for example, with the firmware, because of course the server is the same, the name of the server is the same, but it's not working, right? So having the own hardware, there are some challenges with that, especially, for example, with the networking that you have more ports. There's, of course, you ask IT guys to set it up as same as other servers. But it's not the same.
They will try it, but it takes ages.
Yep.
And they won't do it.
So, and imagine the scenario. We speak about the big data data plane, where there are, at least hundreds of servers, and you can add there more like every week. It's not that you will just add there one time or one per year. You can add there maybe every month, 10 of servers. So you should be pretty sure that it will work, that everything is the same or it will work. And I'm not sure how many of you tries it, to add nodes. I mean, not the same ones, but for example, another queues in hyperscalers to the cluster. Yeah. And in on-prem, it's even worse.
And then let's say you solve all these things, but one day, the day before, everything was working fine. And you wake up one day, maybe in the middle of the night, and there's something wrong. Something is not working. You were just a victim of a hardware failure. So what do you do in this case?
Yep. I think you will just pray that it will be fixed automatically, because the Kubernetes should fix everything automatically, right?
Automatically with hardware, right?
Yep. So, but it's it's even not the edge case, because you can have even more issues with that. Because you can, in enterprise world, especially with the sensitive data, you can have also clients which requires running Kubernetes without internet connection. Okay, so you have to set up your cluster that it works. I mean, not only spin up, but also everything without the internet connection. So you still use some binaries or like RKI2 or stuff like that for the spin up it, but you don't have the OCI. You don't have anything where you can fetch these things. So
you need to do it yourself again
and again. So you will just reinvent the wheel from the scratch. So
then comes you have your cluster running. It's pretty big. Everyone is happy, but more and more teams start using this cluster, and you start hitting some issue. Maybe one team is deploying something which will affect or break the work and the application of everyone else. And you are in the middle of this. You didn't do this. Other people did it, but it's your cluster. So this is your fault, right? And you start to need to have to handle the multi-tenancy issue. How to achieve that?
Yeah, of course, there are some solution how you can deal with that. And the first ideas is, hey, there's, for example, sensitive product like vCluster. So I can run cluster inside the cluster. It's cool, right?
But who knows what vCluster is?
Oh, there are some of them so good. So it's just that, imagine that you can run really cluster in cluster. So you can, separate the control plane. And you don't have to take care about, for example, API limits and stuff like that. So it's cool. Maybe it's the best solution. But again, imagine that you have big company which has not 10 of teams, but maybe 1,000 of them. And you can run it. There are some companies which are running hundreds of Kubernetes clusters in Kubernetes clusters, but it's hard to maintain it.
But the problem also is that everybody is running in the same cluster. I mean, they get their own virtual Kubernetes, but under it, this is still the same cluster. So if a given team starts to get crazy in terms of storage use, in terms of compute resources usage, this will affect other teams, and you are back to the same problem.
Yep. And also there are issues with the DNS, because DNS is working all the time, of course, right?
All the time.
All the time. And if there's any issue, so it's not the DNS failure, of course. But yeah, I think if you're running storage in Kubernetes in Kubernetes, and you have the big data, so you should take care about the disk performance, because running you just add another layer, which maybe the performance will really drop down, and you have to deal with it. Of course, there are some alternative solution, but still, it's not what maybe you are looking for. And mainly, you try to find a solution for the isolation of these projects. So maybe you can start like, okay, I can do it like isolation on the namespace base. Then you can add there some rules. Yeah, it's somehow working if you have the good day.
But in the end, it's still the same Kubernetes API, the same cluster. So you are not fully independent from what the others are running.
Yeah.
This is not enough still.
Yeah, because when you kill the Kubernetes API server or the etcd, yeah, it's dead. So yeah, in this scenario, you have to run the Kubernetes in Kubernetes or create some proxy which will do some rate limiting, maybe also the security hardening. And why are you doing it? Maybe it's better to run a cluster next to the one. So
And here comes the complexity, because you have a bunch of hardware. Some nodes, they have some disk because you want to have storage, right? You have a load balancer configured, but instead of managing one big cluster, you end up with having to share the hardware between multiple clusters, and this becomes complex. So what to do in this case?
yeah, as Cedric said, if I have more clusters, so maybe there are some dependencies that I wanted to be communicating cluster A with the cluster B, and cluster B should be communicate only with cluster C and stuff like that. So there should be some MS, of course. Yeah, of course you can, set up the service mesh. Yeah, it's the best solution. I think you are already using Istio for that.
But at the same time, you want to provide some isolation with new clusters. You don't want that one cluster getting crazy in terms of packets start affecting the other clusters. So the solution for that is to have an abstraction to handle that for you. All this to make hardware behave like the cloud. So there are solutions for that, like OpenStack, for instance, VMware, or Harvester from SUSE and Rancher. So you end up with having hardware, but you give to that hardware some abstraction which you can use to provide isolation. And you can create inside it virtual machines, which provides this additional layer of isolation.
Yeah, maybe, in this scenario, say, hey, come on, guys, we shouldn't do that in this way. But you can make a deal that, okay, it's good enough. And then you go to the enterprise customer, and they said, hey, you have to be compliant with the FedRAMP. You know what is FedRAMP? If not, you are a lucky one, trust me. Or maybe you should know the FIPS 140, free. There are some restrictions of what it's required for the connections, not only for the connection inside outside of the cluster, but also inside in the cluster, the connection to the storage, and also everything should be encrypted, and then fun happens.
And the OS must run, the kernel of the OS must run in a certain mode. You are forbidden to use some specific encryption algorithm. All the algorithm you use must be compliant with and certified in some cases with FIPS. And on top of that, you need to build special binaries to work with that. Special kubelet, special containerd, and it becomes really complex.
Yeah, it's fun. It's fun. And yeah, we already mentioned that you can have also, the most problematic part, and this is the way that clients, ask for that. Hey, I'd like to run the Kubernetes cluster without the internet connection. So you have to pack it up everything that you can provide them as the package. Yeah, and imagine that you will get hardware, and you have to spin up there the Kubernetes. They don't care about how and how it will be working, but it should be high availability. It should be self-healing. It should be almost everything, and you don't have the access there. You can't even get the logs. You have no visibility. So
No visibility, exactly.
Yeah, no visibility. So yeah, you have to create like, maybe it's not only PaaS, but we can call it like SaaS on-prem without internet. So yeah, it's quite funny. And of course, there are some solutions how you can deal with it. We will show it to you in the end that how we will do that with it. But we will just try to say the story why we ended up with our solution. So it's not only about why you spin it up, because of course spin up is the crucial part, but you have to also operate it, right? Because again, it can crash. So what can crash?
What can crash? What do you think?
Any idea? No.
No idea.
No,
It's
just look at this previous picture. They are not the same. It's changing, right? There are some cross with some comments. What can be change? So okay, this is the slide. So Cedric just try to show it to them.
So you have been running your cluster for some time. Everything is fine, and then one day it doesn't work. etcd start to be slow. Your application depending on it don't work anymore, and you don't know what to do.
And also sometimes clients said, okay, I need an upgrade of the cluster because there are some security issues. And you can try to say that, hey, it's offline, so why you take care about it? Say, hey, no way, you have to provide us the upgrade without connectivity. So yeah, it's fun that you have to prepare another binary which he can just run it on maybe on his laptop, and then he can upgrade the thousands of nodes. And
Sounds easy.
And you can imagine that upgrading. How many of you tries to upgrade more than 100 nodes in Kubernetes cluster? Once, two, 3. In one cluster. With petabytes of data.
Did it go well? Raise your hand if yes. Yeah, amazing. Please come to us.
Yeah, you can also share your pain. So yeah, it's really not easy because it's fun when you have tens of servers. Yeah, because it takes like maybe an hour. But if you have 1,000 of them, so maybe it can run days or weeks, even weeks. And of course, you have hardware, so you can imagine that if you're running the upgrade for weeks, someone can crash. And then what happens if you upgrade the node and it crashed, or maybe it crashed during the upgrade, and it happens to more of them. So you have to make also the recovery mode, and again without no visibility, without no internet access. So again, it should be self-healing. So
So it's very interesting now because you started with a task to run some AI or some big data workload on the cloud, and everything was working fine. Then you were asked, please do the same thing in a hybrid strategy or on-prem. And you were supposed to only care about the workload, and you ended up caring about much more things. You had to care about hardware, about DNS, about certificates, basically everything which was granted to work for you on the cloud. You didn't have to care about it. You needed to care about it now.
Yeah. So one more time, look at the previous, picture and what it changed, right? It seems very similar. One more time. So it's fun, right? So maybe we can, move on. So, the best idea is, to provide Kubernetes everywhere, of course, right? On the cloud, on premise. So maybe we can share how we did it, right?
How we did it.
How we did it. So Cedric, start from the the lowest layer.
So we tried many things over the years. Some things didn't work, especially running Kubernetes directly on the hardware. Because of all this complexity, despite all the recent changes with Redfish and all this API to make the hardware have some API, we are still not there yet. So what worked for us was we have some abstraction, which made the hardware usable, and to make it look like a cloud provider. What we found really stable in terms of isolation or functionality was to run a private cloud solution. We are big fans here of OpenStack, for instance. So you end up having an OpenStack cluster. It provides you many of the solution in the same way as a private cloud does. What does it mean? Load balancing, network isolation, storage, both block storage and share file system for your AI workload.
So it is clear, right? So you will have bare metal and install OpenStack on that.
Easy.
Easy, right? But no. There are some issues that you don't want it to run the OpenStack on the bare metal. So why?
Well, you want to run OpenStack on bare metal, but this is not exactly what you want, because you need a true hybrid strategy to combine. I mean, you cannot do everything in one place. You want to combine all, like Kubernetes clusters running in different locations, some of them on-prem, some of them in the cloud.
So how we can, make it working? So there are one solution which we, tried and it works, at least for us, for our big clients. We just said, okay, we will run the Kubernetes on bare metal, and then you install the OpenStack into this Kubernetes cluster. It's crazy, right? You are just add one more layer, but why? But we already said it. If you wanted to provide like the cloud native from the infrastructure perspective for the hardware. So it's one of the way how we can achieve it. And if you wanted to be really pure hybrid mode, we thought that it's the only way, or working way, in quite enterprise environments. But it's not all, because right now, so you install the Kubernetes on the bare metal, you install OpenStack to this cluster, but you say OpenStack, and you wanted to provide the Kubernetes, so you can just install the Kubernetes into the OpenStack. So you have 3 layers, like Kubernetes, then OpenStack, and then the Kubernetes. It sounds, again, crazy, right? Because you are just adding the complexity of it. But again, imagine that you are trying to add, servers on real time. They can be not only killed or maybe dying all the time, but also you wanted to provide a way how they can, plug in the new ones, especially even every week. So how we will do that? So like, what is the abstraction layer that, right now, imagine, I'm just installed the Kubernetes cluster, right? Or Kubernetes on the bare metal. Then I install the OpenStack. This part is clear. But what about the next layer, the Kubernetes in the OpenStack?
So the Kubernetes in OpenStack is you get the cloud provider experience. It's working like in the cloud.
Yep. And is it the same Kubernetes as, is it the same Kubernetes, in the first layer and the third layer? Or should I use a different one? Because,
The same Kubernetes.
yeah, because, same Kubernetes, wait. When I install the first Kubernetes, I should care about the disk encryption, right? Because it's on the bare metal. I should, try to figure out the upgrade lifecycle, and that's it. And then, how can I use the same Kubernetes cluster, in both layers? So, and it's one question. And second one is, when I install the second Kubernetes, so can I run the application inside there?
Inside the second Kubernetes?
Yep.
Yes.
Or should I create another one? I mean, the 4 layer. So,
Yes, you can.
how? Is there any challenges for that?
No, because you solve the abstraction issue.
Yeah.
Hmm?
So, does it make sense for you? No? It's quite common. Yeah, I know it's complex, but you should go to our booth and we can try to explain to you more. So maybe we can summarize it. Yeah. So we try to explain you that we found that the only way how we can achieve this enterprise grade, it's some union help me, Cedric. Union cover scenario where you can combine the Kubernetes, the OpenStack, and also another Kubernetes, and with of course some CNCF tools about it.
Yeah, hardware is difficult, so you solve the abstraction, and on the top of that, we came to realize that running if you run Kubernetes in different providers, they end up being different. So what worked for us in this scenario was to have the same Kubernetes distribution everywhere, because AKS, EKS, and GKE, they all work in a bit different way, and this end up affecting you. And what really worked for us was to build an abstraction to get really the same stack everywhere, which means that the workload we will be running on this Kubernetes would work in the exact same way everywhere.
Yep. And that's it. Right? Again, I can see that it's 100% sure and clear. Everyone knows how we are running it, right? And it's the reason why there is a space for your questions, because I hope that there will be more of them. So, is there any question?
What is the deepest level of Kubernetes? Sorry. We My question is, what is the deepest level of Kubernetes inside Kubernetes? Inside Kubernetes, have you achieved, and what stopped you at this point?
Practically, you can go very deep, hundreds of layers. Does it make sense? Not really. Is it fun? Yeah.
I think that from my experience, I think we started figure out some issues with, I think, 9 or 10 layers, that it starts, happens that some API calls are, disappear randomly. So yeah, I think it's not a good way, to combine more layers like in Kubernetes or even stuff like that. But if you are combining like 4 or 5 in a good manner, so there is almost no performance drop. So it's no issues with that.
So, what you said was, if you understand the advantage, what you propose is the same flavor of Kubernetes runs exactly same way in your hardware and across all the cloud providers because you abstract how you build on cloud specific ways with a standard way of putting the Kubernetes clusters. Correct?
Exactly.
Right.
To provide the same experience everywhere. No surprise.
Right. But is there a cost issue when you run on cloud? Do you actually manage that separately? And then the other thing is, how do you manage the scale? If you're running, on-prem, how do you scale? Because cloud gives you elasticity, but it comes at a cost. So I run some workloads locally. How do you manage that?
That's an excellent question. How to scale that? Because you have a set of servers. This is why here we'd like to have something on top of the hardware because this hardware is here, it's available. So you like to have something to make it, let's say, elastic, that you have this pool of hardware, it's always here, and you make it like an API. So if a given cluster in a given workload needs resources, it can scale inside the dedicated pool of hardware. Then if you need bigger elasticity, then you can fall back on the cloud because what you have there, of course, the cloud is, we can say there is unlimited space available on the cloud, practically. Okay. Truth to be told, sometimes it's not true. So the idea is you have your basic set of hardware on-prem, and if you have a burst in demand, you can scale in the cloud.
Great. Thank you.
Thank you. We have a bunch of questions in Slido. So let's start with the hot topic that got one like. It's 0. So what would make you reject Kubernetes as the target platform? What would make you reject Kubernetes as the target platform?
Because Kubernetes is complex. Kubernetes is not the solution to everything. If you run a bunch of lightweight applications, you will end up spending more on running Kubernetes when you could just have a private server or a Lambda doing the same thing for a fraction of the cost. So Kubernetes everywhere, yes, but no.
Thank you. The next question is also Kubernetes related. What observability signals are must-haves before calling a Kubernetes data platform production ready?
Well, there are plenty of them, but maybe the better question is what is common to be deployed, or what is common to be measured. Because of course Kubernetes provides you some, basic metrics which you can, take care about. You can also install there some Prometheus and stuff like that, and look at these metrics. But in reality, you don't have to take care about it because you are using the OpenStack. And then, it's the question because when we speak about
What observability signals are must-haves?
Essentially, what the AI running is, you see the problem before everybody else see it. That's the sick part. So your observability should be an already announced system which tells you, but the problem because everybody else see. If your customer, there's any customer, your data platform has a key, that problem you bought customer see. Any tap yours is might be is the answer. Can you repeat this? So they say what observability security must have before calling a rack compression way. So if you're serving customer the aware data, the customers should not see the problem they're going to see, so that he can solve the problem. Yeah, or is a
Right.
that's why they down do the.
I agree with the answer. Yes. Mm.
We can also start from the end, define production ready.
We still have some time.
Yeah, I think we have time for like 2 last questions probably. How do you handle node failures when storage is attached to specific zones or nodes?
So specific node is an easy question because as we discussed, we want hardware to behave like a cloud. So in any case, you can migrate the workload of the VM somewhere else. Then about zone, it's more complicated because if a given zone is unavailable and your hardware is running in that zone, the only answer to that is to build a solution based on redundancy. That if a certain zone goes down, you have another one ready to take over, right?
Maybe I have small things. How do you define zone? There are also some hyperscalers which provides you free zones, and it's running in free. It's running in the same building, but just on 3 different floors. It's in Asia, one of the hyperscaler.
Okay. I think the last question, because we will have to end for the group photo. So let's pick up this one. What if you just quit the job and went to work on a farm instead? What? Yeah, it's already there. I see the astonished face. What if you just quit the job and went to work on a farm instead?
I'm already working on it.
Contributing on or farming while working for Clouder. Nice. All right. Thank you so much. Big applause for Zdene and Zdene once again. Thank you.
Thank you very much.
And everyone who wants to be in a big conference group picture, please head in front of the building. If I'm not mistaken, we will be taking a picture in like a minute or 2 there. Thank you. And authors of those remaining questions, feel free to catch up with Zdene. He's of course available to answer it in person.